Okay, question 9 says, which of these is a vector? So we've learnt about there are scalars and they just have a magnitude or a size. And for a foundation paper, you're happy just going, there are things that just have a number, they just have a size. And there are vectors, they have a size and they have a direction. So which of these has energy scalar? Force has a direction and a size. So it's got to be B, that. State the equation that relates acceleration to change in velocity and time taken. So we know that A equals V minus U over T, and that is the change in velocity. And I think you can write this in a range of ways. We go A equals V minus U over T, or A equals the change in velocity divided by time. A van accelerates from 2 to 20 in 12. Calculate the acceleration. So we need this, which will be in your formula sheet. Sorry, you could have written the other one like that if you wanted. A equals V minus U over T. Now we plug in the values. So V, final velocity, it finished at 20. U, it started at 2. That was the initial velocity, divided by the time taken, 12. So that becomes 18 divided by 12 equals 1.5 meters per second squared, or meters per second, your change in speed per unit time. Next one is a velocity time graph. So we know that it's the area under the graph. And you know that triangles are length width over 2. So it's find that value, multiply them, times them by 2. Nice and easy. Remember, if it was something moving at a constant speed like that, we'd just take the full length width. We don't have that, we've got a triangle. So we're going to measure that, 7, measure that, 15. The triangle's length width time over 2, or the distance equals 7 times 15 divided by 2 comes to 52.5. I think that's a nice easy 3 marks at the end of a paper. Next one, 6 marker. The mark scheme, I don't think the mark scheme's laid out particularly well in terms of marking this. So I've given you a model answer that meets all the marks, but it just sticks to the basics of explaining stopping distance equals thinking distance plus braking distance, because this is going to ask you to what involves the driver, what involves the car. So many factors affect stopping distance, and we know stopping distance equals thinking distance, not time, plus braking distance. Some of these involve the driver, that's that bit, the thinking distance. Some of these involve the car, that's the braking distance. Now obviously the driver can have a say on speed that affects both. Explain how the stopping distance for car is affected by those on the driver and those on the car or the road. You should include examples in your explanations. Now, ultimately, examples are tell us if it's going to increase it or decrease it. Describe it. Don't just say what it is, say the effect that it's going to have, because you can see there the effect. So, in terms of my model, you can see, oops, you can't see because it's under all my doodles. Just get that out straight away. State what stopping distance is. So stopping distance equals thinking distance plus braking distance. And if you wanted to, you could say, well, the thinking distance is mostly the driver. The braking distance is mostly the car. Obviously, I've said speed. The driver can change that. That'll affect both. The factors affecting the driver are the things that will change their reaction time. So we're going to talk about that. So what can they do to change their reaction time? We could then actually say the thinking distance is their speed times their reaction time, if you really wanted to show off to a higher tier level, really. So we're going to say that they're off their head on crack. So drugs, tiredness, distractions, there's 3 marks. But can you see I've stated how will it change it? If you're on those, your reaction time will be loads more, and therefore it'll increase the thinking distance. Done. Which is a component of stopping distance. Now let's go and do the braking distance part of the car. Factors affecting the car will change the transfer of kinetic energy to thermal. So the car's moving, it's got kinetic energy, half mv squared. And that always gives us a clue what we can talk about. M, the mass of the vehicle, V, the speed or the velocity of the vehicle. And the basic thing is, how does a car stop? It's got to change its kinetic energy into thermal energy in the brakes and into the road. So we can talk about brakes and roads. So increasing the mass of the car, having a faster speed and having worn tyres will increase the braking distance. And now you can see I've put increasing will increase it. If you wanted to, you could reverse it. All right. And then I'd have to change from worn tyres to fabulously grippy tyres. But now we're done. And that's the best way of answering that, I think.